in this hypergraph, this sort of limiting structure, when you have a very big hypergraph, you can think of as being just like, water seems continuous on a large scale. So this hypergraph seems continuous on a large scale. One question is, how many dimensions of space does it correspond to? So one question you can ask is, if you've just got a bunch of points and they're connected together, how do you deduce what effective dimension of space that bundle of points corresponds to? And that's pretty easy to explain. So basically, if you say you got a point and you look at how many neighbors does that point have? Okay, imagine it's on a square grid. Then it'll have 4 neighbors. Go another level out. How many neighbors do you get then? What you realize is, as you go more and more levels out, as you go more and more distance on the graph out, you're capturing something which is essentially a circle in 2 dimensions, so that the area of a circle is pi r squared. So it's the number of points that you get to goes up like the distance you've gone squared. And in general, in d-dimensional space, it's r to the power d. It's the number of points you get to if you go r steps on the graph grows like the number of steps you go to the power of the dimension. And that's a way that you can estimate the effective dimension of one of these graphs.
So what does that grow to? So how does the dimension grow? Because, obviously, the visual aspect of these hypergraphs, they're often visualized in 3 dimensions.
Right.
And then there's a certain kind of structure. Like you said, there's a circle, a sphere. There's a planar aspect to it,
right.
to this graph, to where it almost starts creating a surface, like a complicated surface, but a surface.
Yeah, right.
So how does that connect to effective dimension?
Okay, so if you can lay out the graph in such a way that the points in the graph that the points that are neighbors on the graph are neighbors as you lay them out, mm-hmm. and you can do that in 2 dimensions, then it's going to approximate a 2-dimensional thing. If you can't do that in 2 dimensions, if everything would have to fold over a lot in 2 dimensions, then it's not approximating a 2-dimensional thing. Maybe you can lay it out in 3 dimensions. Maybe you have to lay it out in 5 dimensions to have it be the case that it sort of smoothly lays out like that.